Here omega is complex cube root of unity. So what is exactly meaning of this? We know for 8, 1 cube root is what? 2, because 2 cube is 8. But actually there are 3 cube roots, from which one is real number, that is 2. 2 cube is 8. And remaining 2 are complex number. Same for 1, that is unity. 1 cube root is what? 1, because 1 cube is 1. And remaining 2 are complex numbers, which we write omega, and third we write as omega square. So these 2 are complex numbers and these are cube roots of unity. Okay, so now omega is complex cube root of unity. So important property, now remember this as omega cube is 1. First property is omega cube is 1. Second property is when we add given 3 cube roots of unity, 1 omega and omega square, our answer is 0. We will check this in some next video of these cube roots of unity. But now just remember properties. 1 plus omega square is 0. And third property is omega raised to 4. We can write omega into omega cube into omega. So omega cube is what? 1. So 1 into omega is omega. So just now remember these properties. So using these properties, we will prove that 2 minus omega into 2 minus omega square is equal to 7. Okay, so let us start with LHS. 2 minus omega into 2 minus omega square. So 2 into 2 is 4. Then 2 into minus omega square minus 2 omega square. Okay, so 2 into this bracket. 2 into 2, 4 minus 2 omega square. Minus omega into this bracket now. So minus omega into 2, that is minus 2 omega. And minus omega into minus omega square, minus minus plus, omega into omega square is omega cube. So minus 4. Now here we can write common. We can write minus common, we can write 2 common. Also we can write omega common. But don't write omega common, because if we write here minus 2 common, we will get omega square plus omega, and we want this omega plus omega square because we can use this here property for that. So that's why don't write omega common, just write minus 2. From these 3 parts, try to write here 2 parts, that is what? Omega plus omega square. Now omega cube is what? 1. Omega cube is 1. So 4 minus 2 into. Now as we know, 1 plus omega square is 0. And so this omega plus omega square is what? Write this one here. So omega plus omega square is minus 1. Plus this one. And so 4 minus 2 into minus 1 is plus 2 plus this one. 4 plus 2, 6 plus 1, 7. So that is what? That is our RHS. Okay? Here question is prove that 1 plus omega minus omega square whole raised to 6 is equal to 64. Now no need to find whole raised to 6 by that binomial theorem. Here question is actually very simple. Omega is complex cube root of unity, and so we know that omega cube is 1 and 1 plus omega square is 0. So we will use this here. So 1 omega and omega square, these are 3 parts here. So if from these 3 parts, here 2 parts are given, use that. Omega square is given is minus, that is not here minus, so don't use this. But 1 plus omega, see here, this is same 1 plus omega. So for this 1 plus omega we can use this. 1 plus omega is what? Minus omega square. So start with LHS. 1 plus omega minus omega square raised to 6. Now this 1 plus omega write as minus omega square write in RHS. So 1 plus omega is minus omega square minus this omega square raised to 6. So like minus x is what? Minus 2x. So minus omega square is minus 2 omega square raised to 6. Now minus raised to 6 is what? Plus. Minus raised to even number, that becomes plus, because minus into minus is plus. So this will become plus 2 raised to 6. 2 into 2 into 2, right? 6 times. 2 into 2 into 2 is 8. So again into 8, that is 64. And omega raised to 2 into 6, 12. Now how we can solve this? Omega raised to 12. Write this first as omega cube raised to. So how we can write raised to? Divide 12 by 3. 12 by 3 is 4. Okay, so 3 4s are 12, that we know. So now 64 into omega cube is 1 raised to 4. 1 raised to 4 is 1 into 64 is 64, that is our RHS. Here question is, prove that a plus b omega plus c omega square upon c plus a omega plus b omega square is equal to omega square. Now as usual we can start with LHS and prove that it is RHS, or start from RHS, prove that it is LHS. But here there is one simple technique which we can use. Suppose we want to prove that a upon 2 is equal to b. Then we can prove that a is equal to 2b, because that is same. These two we can write here. Okay. So if we have to prove that a upon 2 is equal to b, prove